In what ways does 13C NMR or CMR help to elucidate the structure of the carbon skeleton of organic compounds? What are the key differences between 1H NMR and 13C NMR in terms of their applications and the information they provide about molecular structures? What is the importance of solid-state NMR SSNMR in the characterization of the storage processes and coordination structures of sodium ions in both electrode and electrolyte materials? How does the SSNMR technique help to analyze the behavior of sodium ions in these materials? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the principle behind the SSNMR technique and how does it involve the rotation of the powder sample? Why is it necessary to simulate the rapid motion of molecules in solution during the SSNMR process? How does rotating the sample rapidly eliminate unfavorable factors that could broaden the peaks in the NMR spectrum? What is the role of good resolution in obtaining an effective SSNMR spectrum? What is the technique called that enables the sample to rotate in a way that simulates the motion of molecules in solution, and why is it important for obtaining clear spectra? How does the magic angle rotation technique work, and why is it essential for the SSNMR process? What happens to the solid hydrogen spectrum when the sample is rotated at static or low speeds, and why does this cause the spectrum to appear very broad? What effect does increasing the rotation speed have on the SSNMR spectrum, and how does it lead to the formation of continuous peaks with some distinction? What occurs when the rotation speed is further increased, and how does it allow independent peaks to be clearly distinguished? In addition to these rotation effects, what other characteristics does the SSNMR technique have, and how do these features contribute to its effectiveness in analyzing material properties and molecular structures? How does the SSNMR technique compare to the solution NMR technique in terms of sample measurement capabilities? Why is the solution NMR technique limited by the solubility of the sample, and how does this affect its ability to analyze samples with poor solubility or those that deteriorate after dissolution? In what ways does SSNMR overcome these limitations, allowing it to measure a broader range of samples? How does SSNMR provide advantages over solution NMR when it comes to detecting various nuclei, including 1H, 19F, 13C, 15N, 29C, 31P, and 207Pb? And how does it extend its capabilities to quadrupole nuclei such as 2H and 17O? Why is SSNMR particularly valuable for analyzing quadrupole nuclei, and what impact does this have on the types of materials it can study? How does the SSNMR technique allow for the in situ analysis of the kinetics of corresponding physical processes, and why is this ability crucial for fully understanding the relevant processes in the materials being studied?